Here you see the USB AX oscilloscope module. Currently the AX pod is not plugged into the PC. As soon as you plug the pod into the PC, you will see that the pod is detected. The pod ID is shown in the window. And if you had more than one pod, you would be able to drop this list box down and actually change which pod you are talking to. It automatically comes up in auto trigger mode, and you can easily find your signal that you have connected to either your channel 1 or channel 2 connection simply by pressing this auto setup button. It steps through the various rates and sets the analyzer to the appropriate trigger level and scaling for the time and voltage divisions for this particular signal. In this case, we have a sine wave attached. If we switch over to a triangle wave or a square wave, you can see that it changes immediately. The oscilloscope basically runs as a normal analog oscilloscope with trigger levels that you can specify either the rising edge or falling edge. Here we have rising edge. We can change it to falling edge, and you can also change the signal trigger level by the trigger position bar here. In normal mode, if the trigger is outside of the signal range, you see that the triggered symbol does not light. Once you move the position back into a voltage range within the wave, it will come back and start displaying again. You can then zoom in and zoom out of the wave that you're capturing, as well as change the voltage per division by changing the knob positions as with a regular scope. You can also set cursors by changing the position of the cursors in these cursor bars. There's a gray bar here for the time cursors and a gray bar here for the voltage cursors. You can change the position by pressing the left mouse button for the X1 cursor and pressing the right mouse button for the X2 cursor. Similarly, you can press the left mouse button for the Y1 cursor and the right mouse button for the Y2 cursor. Once you place cursors, you can go down to the measurements window and see the position of the cursors, the time between the cursors, the frequency of the time between cursors, where the trigger position occurred. In this case, it's at the center of the screen on the red cursor. You can see what voltage is being measured at the particular Y cursors, and you can also see the automatically updating automatic measurements of the max voltages, min voltages, the top of the waveform and the bottom of the waveform, and the frequency actually being measured of this signal. For high-speed signals, as in the rising edge of a square wave, you can actually get much better resolution when you zoom in. You'll see here we're sampling and it's being drawn, the display is being drawn as vectors, meaning a line from point to point. If you change it to basically pixels per sample as opposed to vectors, and you can turn on persist, and you will see that it will draw the actual falling edge of that waveform in much better resolution than just the vectors. You can also clear the display to start over, and you can change the pixel size to a much smaller pixel size to even give you more resolution. Wider in most cases, though, is much easier to see. Thank you for using the USB AX digital oscilloscope. If you have any questions and need help, further assistance, you can either refer to the user's manual, which is in your USB AX program files directory, or you can contact us at support@usbee.com.